Changes in rainfall and other forms of precipitation will be one of the most critical factors determining the overall impact of climate change. According to Scientific American, climate models predict that the addition of heat-trapping gases in the atmosphere will shift the precipitation in two main ways. The first shift is in a strengthening of existing precipitation patterns, so as the wetter get wetter and the drier get drier. And the second shift is a change in storm tracks, which should move away from the equator and toward the poles as atmospheric circulation changes. This map of precipitation in 1995 has very few spots that are completely white, meaning zero rainfall. Specifically, in the middle of the poles are the whitest spots, while the edges receive much more rain. This map shows the rainfall last year, 2015. The darker blue spots from the previous year have faded into a lighter blue, meaning less rain. In 20 years, 2035, this is the predicted precipitation. The maps continue to show less rain. Specifically, the right map is having less rainfall all around the edges, while the left map is having less rain just in the middle of the pole, but more rain around the edges. In 2055, not much has changed besides the Arctic receiving a slightly less amount around the edges. In 2075, the predictions have still not changed much from the past 40 years. One noticeable difference, though, is the Antarctic pole is more covered with light blue than the initial completely white spots, indicating more rain over the years. Although these regions have very few plants, some do grow here. Climate warming increases the occurrence of repeated freezing and thawing, which leads to the formation of an ice crust, sometimes killing the plants. Because these plants, like phytoplankton, form the base of important food chains, providing primary winter food sources for reindeer and caribou, also other species, their decline will have far-reaching impacts throughout the ecosystem.
Starting in 1995, there is a slow decline in snow and ice coverage on both the poles. Each graph, 1995 through 2075, shows the decrease in snow and ice coverage as the Earth begins its long process of warming up. As you can see in 2015, the snow and ice coverage continues to decrease. The next 20 years leading up to 2035 shows no major changes except a small decrease in overall size. On the graph to your right, the bottom half of Antarctica is decreasing significantly within just 20 years. Coming into 2075, the snow and ice coverage on both poles has declined tremendously. As the poles begin to melt, the emperor penguin colonies in Antarctica could decline by 95% before the end of the century. If sea ice continues to decline at the current rate, this would place the population at serious risk of extinction. Walruses are having a harder time as they rely on sea ice floating close to land on which to haul out. As this sea ice disappears, some walrus pups drown at sea and others are crushed to death during stampedes on crowded beaches. As the carbon increases, it reduces the krill population. Once the krill population declines, animals that rely on krill will be reduced.
You can see a dark blue circle in the Arctic on the map to your left. The dark blue in the Antarctic is very prominent in 1995 on the map to your right. 20 years later, in the 2015 map, we can observe the blue circle in the Arctic is getting lighter. The dark blue in the Antarctic begins to decrease in size. We can barely see the darker blue circle in the Arctic now on the map to your left, 20 years later in this 2035 map. The dark blue on the Antarctic is covering less ground, while the yellow begins to advance to the poles. The yellow and orange temperatures are winning more ground on both maps that show data for the year 2055. We can see that the darker shade of blue region is smaller than it was in the year 2035. The darker shade of blue circle is now on the verge of disappearing in the Arctic region on the map to your left. The darkest shade of blue on the Antarctic region is a third of its original size in 1995. The yellows and blues I have been referring to are not just colors. They tell us our planet is getting warmer because of our extensive use of heat-trapping emissions. In order to effectively address global warming, we must significantly reduce the amount of heat-trapping emissions we are putting into the atmosphere. As individuals, we can help by taking action to reduce our personal carbon emissions, but to fully address the threat of global warming, we must demand action from our elected leaders to support and implement a comprehensive set of climate solutions. We have many options to reduce the rise in surface air temperature, hence global warming, such as using power strips in your home office and home entertainment center, upgrading your refrigerator and air conditioner, especially if they are more than 5 years old, buying less stuff, reducing, reusing, and recycling. It's not just about pollution, but the strategy will lower your emissions too and help combat global warming. Let policymakers know you are concerned about global warming. Our elected officials and business leaders need to hear from concerned citizens. Spread the word.